2.5 Admins, episode 248. I'm Joe.
I'm Jim.
And I'm Alan.
And here we are again. And before we get started, your customary article plug, Alan, is Maintaining FreeBSD in a Commercial Product. Why Upstream Contributions Matter.
Yeah, and so in this article, we talk about the advantages and the elimination of technical debt and avoidance of future problems that come from upstreaming changes that you make that are not part of your core IP back to the open source project that your product is based on, how this helps both foster the community and gain goodwill on your part, but from a business sense also means that next time you go to uplift to a newer version of that open source product, there are less divergences for you to have to deal with and that you have more buy-in and adoption upstream.
Right, well, link in the show notes as usual. TrueNAS 2504 came out last month, and they have dropped FreeBSD. It's gone Linux only. Now, we knew about this months ago, but it seems to be picking up quite a lot of attention. And there's now even a fork of the old FreeBSD version called Zpool.
Yeah, so for a while now, there have been two versions of TrueNAS. Well, actually, three versions. The first being TrueNAS Core, which is based on FreeBSD, and it was, I think, version 13.0. And then there was TrueNAS Scale, which is based on some derivative of Debian and was experimental only. But with the release of, I guess they're calling it Fangtooth, the 2504 version, they've basically saying the Linux version is now the prime version, and they're retiring the FreeBSD version. They did, as a promise, release a updated FreeBSD version based on FreeBSD 13.3, although if you go to their download site, it's kind of still trying to nudge you to the old 13.0 based one instead, because they didn't do the same level of QA on this new 13.3. That is kind of just a last release because they promised they would do one.
And to any listeners who might have been reading my coverage of Scale's initial announcement back when I worked for Ars Technica, and IX was just absolutely swearing up and down, no, we are FreeBSD for life. This is a different additional product. It is not intended to replace. For all of those of you in the comments who were very skeptical and said, nope, this means FreeBSD is dead for them and they're just going to eventually go to Linux. Well, I guess you guys win the Cupid doll. Congratulations.
There are some other changes between what finally came out as 2504 and what was announced as Scale back that Jim was talking about. The reason why it was called Scale is it was going to have these scale out features using Gluster, but that is all since kind of been overcome by events and they don't have that functionality now, but they do have integration with KVM to do virtual machines and obviously Docker and Kubernetes and that kind of stuff. It's a bit unfortunate to see them decide to go that direction, but I can understand why they did. And at the same time, can understand why lots of people don't want to continue down that path. And so there is the Zpool project, which is basically, taking the open source bits of the last FreeBSD version of TrueNAS Core and rebasing it to the new 13.5 release of FreeBSD to minimize the diff with, apparently from their website, their goal is eventually to get it up to modern versions of FreeBSD and possibly someday to the point where it's just a package you install on FreeBSD rather than its own distribution.
I think it's going to be really interesting to see if that Zpool project gets a lot of traction and is, long-term self-sustaining, because it's starting to kind of feel like IX Systems is just spawning these communities. They take a project and they take it in a wildly different direction that alienates a lot of the user base, and then you have a community left behind. We still have XigmaNAS after all these years, which is a rebranding of NAS for Free, which was the fork of the original FreeNAS that when IX acquired the project and took it in a different direction, people who didn't like that went with what was left. Now we have Zpool doing the same thing after another major pivot many years later. And I just wonder, how many times can this happen and leave actual vibrant communities that keep sustaining themselves going?
Yeah, it's the miracle of open source.
I'm not sure I could think of any real good competing examples for other projects. I mean, usually you have, a major change of direction and you have a fork, and sometime between 6 months and a couple of years later, either one fork or the other dies or the two merge back together again. Mm-hmm. Kind of like how Samba NG eventually merged back in with regular Samba, after that fork. Or, you look at the forks of Audacity from the, folks who got upset about the telemetry stuff, and that just kind of tends to die. But this like leaving really successful versions behind thing, that feels a little unique. Can you think of any other examples of that?
I don't know about successful, but Dev 1 springs to mind.
Yeah.
Which is the Debian fork with no systemd.
Right, but I'm feeling a bit more like, to Jim's point, that this tends to happen when it's less a fork in anger and more of literally a fork in the path, where one version is going to go one way and focus on something different, and the other version is going a different way. And it's not necessarily that somebody's taking their toys and going home so much as somebody's like, no, I think that there's still value in doing it with FreeBSD. But yeah, I can't think off the top of my head of many other examples of, forks that actually survived that long. There are not that many that, to Jim's point, that a couple years later you would still find being maintained by more than maybe the one person who forked it.
Yeah, I think the real make or break for Zvault is going to be, can Zvault amass enough of a community to have it actually continue as its own project. I think if they're reliant on trying to figure out how to backport, patches and feature updates from what is now TrueNAS over on the Linux side back over to what they're doing and try to keep it going on FreeBSD, I don't think that'll have the momentum to succeed. But I think it would be great to see, again, something more like a XigmaNAS, that it's like, no, like we have a project and like a purpose and a community that sustains that. And you really just do have a different option, not just like a reskinning with like a different set of people, but an actual whole new ecosystem. I think that's pretty cool.
Yeah, I definitely think it'll be interesting to see, and also interesting to look at how the version of ZFS might differ between the two. If Zvault gets to a faster release cadence and can follow FreeBSD more quickly, they might also mean newer versions of ZFS sooner, or taking a more cautious approach and not rolling out features early like IX has done sometimes to, in the case of fast dedupe, it worked well. In the case of, I think, was it the asynchronous DMU, that went very badly.
Yeah, I was thinking the same thing. You were saying faster release cadence, and I was thinking more like, oh, how about actually instead waiting for the release to push new features out there in production?
Well, maybe an interesting kind of carve out for Zvault might be more of the kind of LTS type of thing. I've definitely seen people install TrueNAS core and run it for 5 years until the hardware is out of warranty and then migrate to new hardware. Not recommending people do that, but that is definitely something you see in production.
A long-standing bug with ZFS raw send and corruption with encrypted datasets has finally been nailed down and fixed.
We talked about this on the show before and on one of Clara's Ask Me Anything ZFS seminars about, this issue that there was kind of this low hum of people running into it, but never enough detail to really track it down. And after we mentioned it on the podcast, an enterprising user went out and came up with a reproducer. It generally takes 2 to 4 hours of running their script to actually make the problem happen, but it did happen, and you could run it over and over again, and each time it would eventually happen. And that provided enough to actually track it down and get it fixed. So it looks like the biggest part of it is when sending the snapshot, the function that takes a hold on the snapshot in order to stop the object from being deleted while you're working on it and so on, was done with a version that takes an extra flag, and we were setting those flags. But then when we were freeing it at the end, we were using the regular release function, not the one that takes the extra flags and tells it to also free the resources for the key. And so this was causing some bits of the dataset to be allocated and set up for decryption, like loading the decryption key. And then when you release it, it wasn't cleaning up those resources. And so when you went to send it again later, it would think it already had one, but that memory was now full of gobbledygook instead. And so it would use the wrong key to try to decrypt it, and then it would look like there were a bunch of errors. So based on reports from Clara customers and from others in the community, Paul Dignelli and some others from my team dug into this and managed to track it down and find the offending bit of code. And then others from the community took that and managed to run it through the reproducer and find that, no, we can run this for days now and it no longer has the problem.
This was a really cool one for me personally because this was a very long-running bug. It was relatively hard to trigger and reproduce, which is why it took so long to fix.
Yeah, like even when you're actively trying to reproduce it, you'd have to run the script that was doing it in a loop for 3 or 4 hours before it would finally happen.
But up until the point where we had this reproducer script, the one thing that people did seem to keep noticing was that users of Sanoid and Syncoid seemed to trigger the bug more frequently than anybody else, to the point that it kept getting reported as a bug against Sanoid itself, which of course it couldn't possibly be because Sanoid simply orchestrates normal command line commands. It really can't introduce this kind of bug. But this led to somebody tagging me in on the upstream bug at the OpenZFS GitHub. And I mentioned, the one thing that did strike me as different, for a Sanoid or Syncoid user is that I don't use ZFS native recursion. Instead, both of my tools actually walk the tree of datasets manually because ZFS native recursion kind of depends on the idea that everything was created recursively initially and nothing really changes with that structure going forward, which is frequently not the case in practice. Luckily, there is a way to force Sanoid and Syncoid both to use ZFS native recursion. So there in the GitHub thread, I said, hey, if you want to bisect further, you can try, having Sanoid and Syncoid use native ZFS recursion rather than its own manual. And, that way you can see if that keeps the bug from happening. And not too long after that is when Hank B really got somewhere with his work on creating a reproducer script. And then eventually we had a reliable reproducer that could, like Alan said, reproduce the bug in hours instead of months. And from there, folks could start bisecting and figure out, okay, where was this bug introduced? And as of earlier today, I believe, is when Brian Behlendorf finally closed that bug. So I feel pretty good about that. I am not a ZFS developer at all. The only things I've read of the OpenZFS code are comment blocks, and I'm happy with it that way. But it feels like this was a really big community effort that a lot of people contributed to. And it feels good.
Yeah. Once we had that reproducer script, it was possible to do git bisect. Basically, Git will take a range of commits and pick one in the middle and basically do a binary search. So it checks out and builds ZFS from the commit in the middle of this range and then runs the reproducer. And if it crashes, it knows the bug was introduced in one of the earlier halves of the commits. And if it doesn't, then it knows it must be in the later half. And it keeps having until it finds the commit that is the threshold between it didn't crash before this, it did crash after this. And using that, we were able to track it down. And then, Paul Dagnelli from my team wrote an update and says, I have this branch where I've ripped out a whole bunch of different bits of code, but it appears to stop it from crashing. And then from there, we narrowed it down to basically this 2-line patch that fixes the resource management around the dataset, and it appears to solve the problem. And so thanks to Paul and Rob from my team and George and others from upstream, and obviously Hank and everybody else, and also to Clara customers, Fastmail, rsync.net, and NBear for using some of their support time to dig into this issue and get it solved.
So my two questions are, does this mean that ZFS encryption is going to be fine now and people can stop worrying about it? And secondly, when am I going to get these changes as an Ubuntu 24.04 LTS user?
This fixes the known bug with sending with encryption, so ZFS raw send. If you've encountered an issue that's not related to raw send, then you need to file your own bug report and come up with a reproducer, and then we can do this whole exercise over again. But as far as I know, there aren't others.
But to be clear here, Joe is asking about a very specific, long-known bug that's hard to trigger, and is this that bug? And yes, it was. This is the only one that we were aware of. If somebody finds another bug with encryption, then it will be something different. This was the long-running, like nobody really wanted to talk too loud about it, kind of hard to trigger encryption bug. This was the one.
Yeah. Richard Yao, who's been a longtime member of OpenZFS, also created a CodeQL check in the GitHub that looks for this type of bug in the future. So we'll find any other similar bugs if they exist or get added to ZFS in the future. Now to your second question, Ubuntu doesn't update their version of ZFS they ship in the LTS ever. So you will not get the fix until Ubuntu 26.04.
Great.
Unless you, for example, have a subscription for Clara and get access to an updated Ubuntu repo.
I think you're going to have to comp me one, Alan.
But even for everybody else, likely this will get backported and go out as part of the next release of 2.3, but I don't know when your OS might incorporate that. we're going to get a errata notice. So FreeBSD will ship an update to this probably in a week or so, but I don't know about other operating systems.
It's possible that we might see this go out with 2510, but frankly, I kind of doubt it. This is not any kind of insider info, just how long it usually seems to take Canonical to react to new fixes coming out and when things show up. I wouldn't expect this to show up until 2604, most likely.
If somebody knows the right people at Canonical/Ubuntu and would like help getting this fix into their version safely, definitely willing to help. Like the OpenZFS community is willing to help with that. Like, I'm not even saying they have to hire me. I'm saying we will help them ship this update because it would be for the greater good of ZFS if Ubuntu stopped shipping this known bug.
Okay, this episode is sponsored by people who support us with PayPal and Patreon. Go to 2.5admins.com/support for details of how you can support us too. Patreon supporters have the option to listen to episodes without ads like this. And it's not just this show. There's Late Night Linux for news, discoveries, audience input, and misanthropy. Linux Matters for upbeat family-friendly adventures. Linux After Dark for silly challenges and philosophical debates. Linux Dev Time about developing with and for Linux. Hybrid Cloud Show for everything public and private cloud. And Ask the Hosts for off-topic questions from you. You can even get some episodes a bit early. We've got a lot going on, and it's only possible because of the people who support us. So if you like what we do and can afford it, it would be great if you could support us too at 2.5admins.com/support. A completely not clickbait headline here. 5 things I regret about using my Raspberry Pi as a NAS. Normally we wouldn't link to this sort of stuff, but there are some reasonable points here.
The biggest reason I wanted to cover this is because while I still very firmly state, no, you should not be using a Raspberry Pi as a NAS, it's not a good choice for that particular use case. One of the interesting things is that the Pi 5 specifically, since it now has PCIe slots, it is actually possible to put a proper SATA adapter on a Pi 5. And if you go that route, if you get the proper PCI Express, real no kidding SATA adapter, although they still call it a hat on a Pi, because of course they do, that removes my biggest objection, which is just that you should never rely on 24/7 365 USB connected drives. It's not what that protocol was designed for. It doesn't get handled well. Well, if you got proper SATA, that issue disappears. However, you're still left with a weird little cheap, although not as cheap as it used to be, thing that doesn't perform very well and has very limited connectivity options that looks like an octopus making love to a hat rack because now you've got multiple cables, strung out to multiple external drives somewhere else. And it's kind of like, you could have done better than this. Maybe look at something that's designed to be an NAS in that same general space, like one of Odroid's designs. Odroid has a couple of designs that are purpose-built and designed, the whole thing, the idea being like, yes, this will be a micro NAS that you'll attach 2 drives to.
Yeah, although I stretch to even call 2 drives a NAS. But really, like, if you're going to build something to be a NAS, you want to build something that was designed to have a bunch of hard drives in it. And a single board computer was generally not designed to have a bunch of hard drives in it.
I do think we should avoid getting too prescriptivist here.
Yes.
To get in with, Joe's favorite grammar quibble. Because, yeah, I agree with you. I don't consider something with just 2 hard drives in it to be a NAS. I mean, that might not even be a desktop by my standards, but everybody is an us. And there are literally millions of people out there who very much think of like, I've got redundant storage. I've got a mirror of hard drive. Like, that's a special thing to them. It's an NAS. They want to put it in the middle of their network, topologically speaking, and have it serve files. That makes it a NAS. Is it a baby NAS by your standards or mine? Absolutely. But you know what? I said the word micro NAS. So if it makes you feel better, just think micro NAS every time. And really, you can't argue with that. It's a micro NAS.
Yeah. Does it have storage? Is it connected to the network? Is it serving that storage across the network? It's a NAS.
It is storage, it is attached, and it is on the network. It's a NAS. So anyway, yeah, if you want a very, very small, very power-efficient NAS device, you could definitely do worse than one of the Odroid models. I believe XU2, I think, with an appropriate chassis is the one that you'd be looking for. But you really want to just kind of Google a little bit for that. Odroid is a good vendor for that. But you can get, again, very low-powered, very DIY, make-it-yourself ARM-based devices to make a very small NAS out of. But the Pi is probably not going to be a good fit for that.
I still maintain that low-end x86 hardware is better.
I agree with you 100%. Yes, low-end x86 is way better. You can get it much cheaper. The actual power use differences are nowhere near as big as most people think they are, especially if you're starting out with like a small form factor x86 box that was built off of laptop hardware rather than desktop hardware. You are not talking about much difference, in power consumption between that and, like a Pi grade ARM-based device. They're pretty freaking close, man. So I would agree it is better to go x86, but I just still want to circle back and say I know there are a lot of people who really, really want to make low-powered, low-cost, brand new ARM hardware work for a microNAS. And to those people, I'm telling you, please look into the Odroid lineup, not Raspberry Pi.
If you're talking about 4 or 5 hard drives, the power of those hard drives is probably going to outscale the power of a low-end Intel versus an ARM. Like the difference in power utilization, this power savings you're getting from going to ARM instead of Intel is probably going to be lost by just having a couple of hard drives, or especially getting like 7,200 RPM hard drives versus 5,400 RPM. The power difference there is going to be enough that you're talking like 9 watts a drive when they're busy versus 6, that across 5 drives, that's more power than the Intel or the ARM we're ever going to use anyway. And it just seems like a lot more of this is people wanting the novelty factor of I did it with this little piece of hardware instead of I did a NAS that's good.
Yeah, and in particular, if we're talking about, again, if we're comparing the laptop x86 stuff, not the desktop stuff, the laptop models, if you're beginning with those, and that doesn't necessarily have to be an actual laptop. Again, you can find mini PCs from specialty vendors like Minis Forum or Chodom. You can find small form factor, quote, desktop, unquote, PCs made by big manufacturers like HP and Dell, which if you look carefully at CPU models, they're actually using laptop parts in there. And those things are going to idle typically at under 5 watts consumption. So yeah, you might be looking at maybe 4 watts at an idle on, the laptop x86 powered stuff versus a couple of watts at idle on, the lower end ARM stuff. But even if your drives are solid state drives, while you're accessing them, you're going to be burning multiple watts per solid state drive to actually light them up and use them, read or write. Even idling, they don't differ that much from hard drives. People frequently think that it's a huge power savings to go from hard drive to solid state drive. Nope, they're a lot closer in power consumption than you might think. So by the time you put 2 drives or 4 drives or 8 drives in a box, even if they're solid state, the difference in consumption between mobile x86 and ARM, it's just lost in the wash.
Let's do some free consulting then. But first, just a quick thank you to everyone who supports us with PayPal and Patreon. We really do appreciate that. And if you want to send any questions for Jim and Alan or your feedback, you can email show@2.5admins.com. Another perk of being a patron is you get to skip the queue, which is what Penny has done. Penny writes, I've enjoyed the many discussions about using ZFS on the show, but I don't recall the Zpool checkpoint feature ever being discussed. What are the best use cases for Zpool checkpoint? Do Jim and Alan have any real-world examples of how they've used it effectively?
So the Zpool checkpoint feature was created by Delphix, which was an appliance company, to deal with their upgrade process. So because Delphix was a virtualization platform built on ZFS specifically for Oracle databases, so it would allow you to basically use ZFS clones and so on to spin off development versions of your main product database and use it in developmental software and so on. And it basically allow your developers to have access to a version of the database they can play with and test schema updates to or performance tests or whatever they want to do without necessarily causing problems for the main production use. And so when it came time to upgrade to a newer version of their appliance, say you're just going to apply OS updates and update the software and so on, they had a big upgrade script that would run. And it would, rename a bunch of data sets, apply a new database schema, and all these other things. But they found the problem they had is every time something went wrong in the script could throw an error and exit. But in order to try to undo what it had done before, it meant they had to write basically the whole script in reverse. So that as soon as it failed, it would undo any steps that it had done, but not undo any steps it hadn't done yet, and so on. And it turned out this was all really complicated. But your normal ZFS snapshots don't let you undo things like creating new data sets or renaming a data set. So they created this concept of the Zpool checkpoint. So this is basically a whole pool snapshot, except for the main limitation is you can only have one checkpoint at a time. But when you create a checkpoint, it basically saves the Uber block, the top level of the ZFS kind of tree of blocks, off to the side and disables the reuse of all space. So normally in ZFS, when you overwrite a file or change something, ZFS writes the new data to a new spot. And if there's no snapshots, after a couple of seconds, the old spot that's not used anymore becomes free space. When you have a checkpoint, that part never happens. Any sector that's ever been used can't be used again while the checkpoint exists, because it would obviously refer to data that the checkpoint might be using. And so checkpoints are only designed to live for a short amount of time. But the original use case was basically to undo a half-finished upgrade on an appliance that might involve creating new data sets and renaming things and so on.
Yeah, because if you left that in place for too long, that could be pretty disastrous in terms of...
Well, you just run out of space.
Yeah.
Much quicker than you might even out of snapshots, because if you write some data and then overwrite it and overwrite it and overwrite it and overwrite it, if you had no snapshots, it doesn't take any more space. If you had one snapshot, only the copy in the snapshot gets saved and the overwrites don't keep reusing the same space. But with a checkpoint, you're eventually going to fill up the entire disk. So as far as real-world use cases, the main one is before you make an administrative change, whether that's resizing a ZFS volume or adding a new disk to the pool or whatever you might want to do, generally, if you take a checkpoint first, it means you have the ability to undo whatever it is you just changed. And we definitely encountered plenty of people who really wish they had remembered to take a checkpoint before running that administrative command that ended up doing not what they wanted because they forgot a keyword or a flag or just typoed something. Like I think one of the very first episodes of the show, we talked about a sysadmin who accidentally changed the size of the wrong volume, changing a very, very large zvol down to a small one instead of changing a small one up to be slightly bigger. And there was no way to undo it.
Zpool upgrade was a big thing that I had in mind for checkpoints.
Yes.
I don't really have any successful, like in the real world, like this is the time I use Zpool checkpoint, it saved me, et cetera, et cetera. I've used it a couple of times and never needed it when I did, but that's basically when I'm looking to take a checkpoint is right before I do an upgrade. You know, if I upgrade the major version of the operating system underneath, then I'm offered a much newer version of ZFS, and there may be some feature flags that are now available, some of which may even involve on disk format changes. Well, it's a real good idea to go ahead and take a checkpoint before you allow that upgrade to happen. That way, if everything goes completely pear-shaped, you can hopefully roll back to that checkpoint and be right back where you started without having to hit the backup.
But then you do have to remember to get rid of it afterwards, right?
Yes, you definitely need to clear that checkpoint once you're sure you don't need it anymore, because you have permanently made every single byte of data that you had in your pool immutable for as long as you have that checkpoint. All of it is immutable until you clear that checkpoint.
Yeah, and that's if you run Zpool status, it'll tell you, hey, there's a checkpoint to kind of remind you of that. The biggest thing is if you want to use the checkpoint, if you decide you need to go back, first of all, this is done by importing the pool back to the checkpoint. So you can't do this while the pool is in use. You have to export the pool and import and rewind a checkpoint. And every change you've made of any kind since the checkpoint is undone. Basically, it made sure none of the old data got overwritten, and it's basically going to throw away everything you changed since the checkpoint. It is very much different than just a snapshot where you can, undo just the changes to one file system, or you could, clone it and pick out just some of the files you wanted or whatever. With the checkpoint, it's kind of all or nothing. You're just rewinding the whole pool to pristinely how it was before, which is an advantage most of the time, but really means you probably don't want it around for very long, because if it's been a while, you probably have changed a lot more than that you're going to miss when you roll back to the checkpoint and every change goes away.
But this could be very useful on the root of a FreeBSD system, like an appliance, say.
For boot environments, the changes are already contained to a dataset, and so you didn't need a whole checkpoint. But yes, if you're doing things where you're going to rename a bunch of datasets or create datasets and then want to undo that, then yes, the checkpoint can be very powerful.
A checkpoint would be a real good idea, for example, before trying out the RAID-Z expansion feature, reshaping an existing RAID-Z array from, say, 4 disks wide to 5 disks wide. Take a checkpoint first. Make sure everything goes well, once it's finished resilvering all of your data on the newly, resized array.
That won't work, though, because it needs the free space to shuffle it into.
Yeah, that's a good point.
Specifically, RAID Z expansion is not compatible with the checkpoint. You can't go back once you change that because the topology changes. But yes, exactly that kind of thing, except for that one specific case.
That would be a good idea if you could do it, but you can't.
Yeah.
Another reason for me personally not to be that big a fan of the RAID Z expansion. I know that's something that a lot of people have wanted for a very long time. It's never been as practical as people want it to be. Honestly, it wasn't very practical, even in the MD RAID and hardware RAID days either. And it just still isn't. There are a lot of problems with doing that. It's better to plan your storage out properly ahead of time.
Right, well, we better get out of here then. Remember, show@2.5admins.com if you want to send in your questions or your feedback. You can find me at joelrest.com/mastodon.
You can find me at mercenarysysadmin.com.
And I'm at Alan Jude.
We'll see you next week.